Okay, today we are going to talk about the assignment 2 in probability and statistic. This assignment contains 3 questions. The first one is we have to consider a random sample, which is from a normal distribution, and the mu is unknown. We have to suggest one estimator for theta, which is defined as a function of mu. And then we have to use it with some limit result to derive a 96% confidence interval for theta. Um, how to suggest a estimator for theta? We have to note the fact that by weak law of large number, the sample mean converge in probability to mu. So we may suggest that the estimator is equal to e to the power sample mean minus 1, just like this. This is really good because it's a function of the sample mean, and the sample mean by center limit theorem, we can obtain that it converges in distribution to a normal distribution. So if we let a function defined by gx, which is equal to e to the power x minus 1, so g of sample mean is equal to e to the power sample mean minus 1. It's just the estimator we suggest. And also, g of mu is equal to e to the power mu minus 1. It's just theta by the assumption of the questions. If we have this function, then we are glad that we can use the delta method, because the delta method told us that if we have this condition and a function, then we can obtain that this result. And this result, we can simplify it to simply get the square n times the estimator minus theta converge in distribution to a normal distribution. And by the normal distribution's properties, we can conclude that the 96%, it is equal to 1 minus 0.04, and it is equal to the probability of this the probability of this result. But we have to know that there is a unknown parameter mu here and here. But we can solve it because we know that the sample mean converge in probability to the unknown parameter, and we can substitute it by the sample mean. So our result is this one. And don't forget to substitute the estimator by the estimator we suggest. And this is the result of this question. Okay, let's see the question B. Question B, we have to consider a random sample from a normal distribution, and this time mu is 10, but the variance is unknown. It's larger than 0, but it's unknown. And we need to construct a 96% confidence interval for theta, which is defined as lowering sigma by using some limited results. We can begin with a fact that we know that xi is from normal distribution. So by normal distribution's property, we know that xi minus 10 over sigma, the the square root of the variance, it's from standard normal distribution. Standard normal distribution is good because if we square this sample variance, this sample variable, and let it denote by y, we can conclude that the yi is from a chi-square distribution. Since it's from a chi-square distribution, the expectation of yi is equal to 1 and the variance is 2. Now, if we let s sub n to the power 2 to be such a thing, it's in mean value form because there is a 1 over n here, and we divide it by the variance, the unknown parameter. We get this result, and this is simply the sample mean of yi. This is good because the center limit theorem told us the Sn sub n to the power 2 divided by the variance converge in distribution to a standard normal distribution. And we have already learned the fact that this thing is converge in probability to the variance. So we may suggest it to be the estimator for, we may suggest it to be the estimator of the variance. And then we can suggest the estimator of theta to be lowering square roots of this thing. And we denote it in this form. The reason why we denote it in this form, because if we let a function g to be gx is equal to lowering square roots sigma square times x, then this function, if we substitute x sub n to the power 2 divided the variance into it, we can get it's equal to the estimator, and g of 1 is simply theta because it's equal to lowering sigma. By using this result and the function g, and we know that the delta method told us if we have this result and a function g, then we can obtain this. This is what delta method told us. And to simplify it, we got this one. Square root n over 2 times the estimator minus theta is converged in distribution to a normal distribution with the variance 1 over 4. So by the same method as we use in question A, 96% is equal to this probability because of this is the probability of this is the properties of normal distribution, and we have to substitute the estimator by the exact form, this one. So that's our result. Okay, let's see question 2. Question 2 told us xi is a random sample from normal distribution where mu is unknown, and we define yi to be if xi is greater than 0, then yi is equal to 1. Otherwise, it's equal to -1. So the first question, we have to write down the likelihood function and find the maximum likelihood estimator for theta, which is defined by the property of y sub 1 is equal to 1. And we are given the information that there are 4 positive data and then 6 non-positive data in our sample. And the first question is quite easy because by the definition of the likelihood function, we can write a likelihood function is in this form. There are 4 positive data and 6 non-positive data. And but this is not the final result because we can simplify it. We know that the probability of y sub I equal to 1 is equal to the probability of x sub y larger greater than 0, because that's the definition. Then we try to minus a mu on both sides of this inequality, because if we do such a thing, we can find that x sub I minus mu is equal to a standard normal distribution. And this is really good because we can simplify this probability to be 1 minus phi of negative mu, and it's just phi mu. Also, the probability of y sub I is equal to the negative 1 is just 1 minus phi. So we simplify the likelihood function to into this form, and we let L to be the log of likelihood function. Then this L of mu is equal to 4 times log phi mu and plus 6 times log of 1 minus phi of mu. And we have to find the extremement value of this function. So we just let the derivative of L to be 0, and we solved that phi mu is equal to 2 over 5. And we check that if phi of mu is equal to 2 over 5, the second derivative of L is smaller than 0. So it's indeed the extreme value of this function. Since theta is equal to the probability of y sub 1 equals to 1, so by the calculation we just do, this is just phi mu. So we can conclude that the maximum likelihood estimator for theta is just phi mu, which is equal to 2 over 5. And that's our result. About the second questions, we have to use the result in A to find an estimator of mu. This is quite easy too, because in A we have verified that mu is if mu is a maximum likelihood estimator, then it must satisfy that phi mu is equal to 2 over 5. And we know that the function phi is an injection. So we just take the inversion of this function to be the estimator of mu. That is, the estimator is equal to the inversion of phi of 2 over 5. So we have done the second question. Now let's see the final question, question 3. We have to consider a random sample of X. The size of it is greater than 1. and it's follow the following distribution, where the theta is the parameter, which is unknown. We denote by the sample mean of x of the random sample. And the first question, we have to find the mean and the variance of x. Okay, this is quite easy because we just do it by using the definition of the expectation. Expectation of x is equal to this one, and we simplify it. The expectation of x to the power 2 is equal to this one, and we also simplify it. Then by the formula, the variance of x is equal to the expectation of x to the power 2 minus the square root of expectation of x. And we substitute the result we just solved into this two thing, and we get the final result of the variance. And then the second question, we have to prove that the estimator, which is defined by 2 times 1 minus 1 over sample mean, we have to prove it converge in probability to theta. And okay. First, let's take a look at the sample mean, because the sample mean is very good because by first of all, the expectation and the variance by A, it's all finite. So the weak law of large number told us the sample mean must converge in probability to the mean, which is 2 over 2 minus theta. So this result. And we have already learned the continuous mapping theorem. The continuous mapping theorem told us if we have a continuous function, then the g of sample mean must converge to the probability to converge in probability to g of 2 over 2 minus theta. And if we define the continuous function to be 2 times 1 over 1 minus 1 over x, then we can find that g of the sample mean is equal to the estimator defined in the question. And g of 2 over 2 minus theta is just the theta. And this is the result. The continuous mapping theorem told us that is the estimator converge in probability to theta. Now, let's see the third question. We have to use the estimator in B to construct an approximated 95% confidence interval for theta with the following data. So in progress, we know that the variance is finite by 1. This is finite. By center limit theorem, we can obtain that the sample mean converge in distribution to a normal distribution. We have to get the confidence interval for theta, and we know that by 2, the estimator for theta is a function of sample mean, and we just let the function to be 2 times 1 minus 1 over x. So we can use the delta method to find the confidence interval. The delta method told us that g of sample mean converge in distribution to a normal distribution. And we can simplify this result into this form. Just like the first question of this assignment, use the properties of normal distribution, we can get that the 50% is equal to this probability. This one is the standard. It's the square root of the variance, in fact, of this normal distribution. Now, we are not done yet because the question told us the exact data of the random sample. So we can verify that the estimator, which is equal to 2 times 1 minus 1 over the sample mean. So by the data, we get the sample mean, and then substitute in it, we get the estimator is equal to 4/7. And we substitute this result into the interval we get. Finally, we have this result to be the 95% confidence interval for theta. And solution D, the question D asks us to comment the interval guess found in C for theta. As a result, this interval guess suggests that the true value of theta lies between the confidence interval derived in C with 95% confidence. However, we have to note that there is only 10 data in this sample. So n is equal to 10 is not large enough to make an interval guess. In fact, so our result, this interval guess, we have to say it's not very good because our sample is not very large. So that's all the solution of this assignment. Thank you for your listening. Goodbye.